Hi guys, welcome back to the channel. Today I'm going to show you how to solve this problem. 9.1. It says determine the mass and the location of the center of mass x bar y bar of the uniform parabolic shaped rod. It says that the mass per unit length of the rod is 2 kg per meter. So the approach is to find the length of the rod, then multiply by 2 kg per meter in order to find the mass. Okay, so let's get started. I've already drawn the shape. I'm going to take DL, small segment DL, and I'm going to integrate through the whole shape. I have here 4 meter and 4 meter, the x and y axis of this shape. I'm going to draw DL yielding dx and dy. So DL using Pythagorean theorem, it will be dx squared plus dy squared. Now I'm going to differentiate this expression in terms of dx, yielding 2y dy over dx equals to 4. Now I'm going to find dx in terms of dy will equal 1 over 2 times y dy. This is the expression. So what I'm going to do now basically is I'm going to replace dx in this expression, and let's get started. The length of the rod dl L will equals from 0 to 4 square root dx squared, which is 1 over 2y dy, this, so it will become 1 over 4 y squared times dy squared plus dy squared. Taking dy common factor, dy squared common factor, yielding 1 over 4 y squared plus 1. Okay, doing some simplification, yielding 1 over 4 y squared plus 1 times dy. Take 1 over 4 common factor in order to leave the y squared alone, yielding y squared plus 4 dy. Further simplification, it will become from 0 to 4. Take the square root of 1 over 4, which will be 1 over 2 times square root y squared plus 4 times dy. So now I'm going to use trigonometric substitution in order to solve this integral. So let's get started. So I'm going to let y equals to 2 tangent theta and dy will equal to 2 secant squared theta d theta. I'm going to replace these expressions with in this equation 1 over 2 integration 0 to 4 y squared will be 4 tangent squared theta plus 4 times dy, which is 2 secant squared theta d theta. The 2 will cancel the 2 outside, and I'm going to take 4 common factor. We yielding tangent square theta plus 1 times secant square theta d theta. Solving this part will become secant square theta, taking the derivative, I mean the integral, 4 times secant squared theta times secant square theta d theta will yield from 0 to 4. Take the square root of this expression, will leave 2 outside. Secant square theta will be secant theta times secant square theta will yield secant cube theta d theta. Now I'm going to integrate this expression. I'm going to use integration by parts. I'm going to let u to be equals secant theta, du will be, I'm going to separate this expression into secant theta times secant squared theta d theta. Okay, so u secant theta du will be secant theta tangent theta, dv will be secant square theta, and v will be the antiderivative of secant square theta. It is tangent theta. So using integration by parts, the function is uv minus integration v du, yielding uv secant theta tangent theta minus integration v du tangent theta du secant tangent. So tangent square theta times secant theta d theta. Doing further simplifications will yield tangent square theta, which is secant square theta minus 1. Okay, secant square theta minus 1 times secant theta d theta minus the integral of secant cube theta d theta, and minus 1, which is plus 1, so plus secant theta d theta. Having this expression, actually I have two here which I forgot. I'm going to use it right there. Integration secant square theta d theta, which is 2. I'm going to make it 2. The 2 from above will equals secant square theta, or secant theta tangent theta minus secant cube theta d theta. This integration will yield ln secant theta plus tangent theta. Okay, now take this part there, will yield 2 secant cube theta d theta will be equals what? Secant theta tangent theta plus ln secant theta plus tangent theta divided by 2, the whole expression by 2. Okay, this will go. Now yielding this expression, this is the integration answer, this is the expression of dl. Okay, now I'm going to convert this expression into y. Having y equals 2 tangent theta means tangent theta equals y over 2. I'm going to draw a triangle like so, triangle like so. This is a triangle. This is theta y divided by 2. This is y squared plus 4. Tangent theta will equals y over 2. Secant theta, it is the opposite of the cosine theta, which is y squared plus 4 divided by 2. Applying the equation, yes guys, this will cancel because I have 2 here. This is 2 is there, so 2 will cancel, so 2 here will be here too, so no need to divide by 2 because we have here 2 already. We had 2 here, so we don't have to divide by 2. So secant theta, which is square root of y squared plus 4, y squared plus 4 over 2, tangent theta, which is 1 or y over 2 plus ln square root y squared plus 4 over 2 plus tangent theta y over 2 from 0 to 4. This is the integral. This is the L segment. Replacing 4 in y, yielding 5.9 something meter. Now if you want to find the mass, you just multiply by 2, as we have in the problem. It says 2 kilogram per meter of the rod, so we have to multiply by 2 kilogram, which is 11.83 kilogram. This is our mass. So if we want to find x bar and y bar, we can do it, no problem. From the center of DL, this is y, this is x. This is the reference axis. Okay, so now in order to find x and y, I have to I'll start with x bar, integral x times dl, which was this expression y squared 1 over 2 y squared plus 4, 1 over 2 y squared plus 4 times x, which is what I have to express x in terms of y. X will equal y squared over 4 times y squared over 4 divided by 5.9 meter. Taking the derivative from 0 to 4, I'm going to use the calculator this time. 1 over 2, and from 0 to 4, 1 over 2 square root y squared plus 4 times y squared over 4. Divided by 5.9, yielding 1.64. This is x bar. I'm going to find y bar, which is just y times 1/2 outside y times dl, which is 1/2 y squared plus 4 dy over 5.9. Use the calculator or use substitution, no problem. 0 to 4 y square root y squared plus 4 divided by 5.9, yielding 2.3 meters. Now what I'm going to do is I am going to check the answer. Question 9.1. Yes, this question, DL, the mass is equal 11.8, x bar 1.64, and y bar 2.29, which is 2.3, x bar 1.64, and the mass is 11.83. And this is the answer. Thanks for watching. See you later.